Have you ever been stuck troubleshooting an equipment issue in the field? If only you had more information to solve that problem. Now you do, thanks to Watermark. Watermark, a leading manufacturer's representative devoted to giving you concise and informative tips about how you can solve that equipment issue quickly and definitively. Go to ewatermark.net to view their library of troubleshooting videos. That's E as in excellence, watermark.net. Hello, Scaling Up Nation, and welcome to the Scaling Up H2O podcast, the podcast where we're scaling up on knowledge so we don't scale up our systems. I am Trace Blackmore. I am the host of Scaling Up H2O. And folks, happy May 8th. Happy May 6th to me. 2 days ago, I actually celebrated my 45th birthday. I don't know how that happened. 45 years old. For fun, I looked up who I share my birthday with, and I actually share a birthday with Sigmund Freud. I don't know if that says anything about me, but I also share a birthday with George Clooney, so I think by default that makes me Batman. And I think that's appropriate because, as you know, I compare water treaters to superheroes all the time. I think it was about 3 years ago on this podcast when I first did a microphone check on a brand new microphone that I received. I've since gifted that microphone to somebody that started out a podcast. But I remember I was just playing around and I did this little thing on water treaters are superheroes. And since that time, I've seen other people post on their social media pages how water treaters are superheroes. So I love that others agree with me. When you think about it, with all the things that nature throws against us, you have to consider us a superhero. Think about it. We protect metals from rapidly corroding. Now, steel, a metal, it wants to corrode. It doesn't like existing in the state that it is in. It wants to exist in a more stable state, meaning it wants to rust. And then we put that metal, we put that steel in water. What we call water the universal solvent. That means it wants to corrode things like steel. So we're putting something that wants to corrode into something that wants to corrode it. And now our job is to protect that metal from rapidly corroding. How else would you define what we do other than we are superheroes? So I hope you spread the word about that. Nation, you've heard me say on this podcast before, whatever area of water treatment you practice, there is most definitely some sort of certification that you can acquire. Now, for the folks that practice the same type of water treatment that I do, that certification is the Certified Water Technologist that's administered by the Association of Water Technologies. Now, we call that the CWT. And there were two individuals that recently achieved their CWTs that I wanted to recognize on the Scaling Up H2O podcast. That is Patrick Shaver. He's of Global Water Technologies. And then Ryan Cochran of Aquatrol. Well, folks, they received their CWTs this year, and I know they are both listeners of the Scaling Up H2O podcast. So you guys are now superheroes in your own right. And folks, if you have not considered looking to see what designation is out there for the type of water treatment that you practice and going after that designation, I'm going to encourage you to do so. By doing that, you are proving to the world that you are in this industry to stay, that you are taking it seriously, and you are doing what you can to raise the bar within that industry. Just like Patrick and Ryan, what can we all do to raise the industry just a little bit? And just think what will happen if we all do that. Now, Nation, can you remember a time where you didn't know what a cooling tower was? Like I said, if you practice the same type of water treatment that I do, you see cooling towers each and every day. But before you got into this industry, you probably didn't know what a cooling tower was. Back then, you never noticed them. But now you cannot help but notice them. They're everywhere. The funny thing is they were everywhere before. You just didn't know to look for them. And now that we know that, I've got this disease where I can't stop looking for cooling towers. They almost just call out to me. I'm not even trying to look for them. And I'll say, hey, there's a cooling tower over there. They call out to me. I think that's something that water treaters that's maybe one of the superpowers that we have. To share a funny story with you, my wife Stacy and I were in Rome, and we were looking at some historic buildings, and right beside that, there was a cooling tower. And I remember I started pointing out some features of the cooling tower to her, and she just looked at me and said, Trace, we've flown 5,000 miles, and you're looking at a cooling tower. And I think I said something like, well, Stacy, you can take the boy out of water treatment, but you can never take the water treatment out of the boy. And of course, she filed for divorce immediately when we returned home. No, that didn't happen. We're happily married. Just a joke. But I just say that because I think a lot of people are like that. They just notice things in the environment, wherever they are, that relate to what they do on a regular basis. Here's the thing about cooling towers. They are very effective at removing heat. And they can be used in just about every industry that you can imagine because of their ability to effectively remove heat. Now, because they're in so many industries, we've developed different terms for the same piece of equipment, and we call cooling towers a bunch of different things. We call parts on a cooling tower a bunch of different things. So if you're now having a conversation with somebody and you call something X and the other person normally calls it Y, you're probably sitting there agreeing with each other, but you have no idea what you're talking about because you're not using that common terminology. Now, if you've ever called a manufacturer of a cooling tower and didn't use the appropriate word, they will probably take the time to educate you or ask you the question, what exactly are you talking about? A lot of times when people say that, they mean this. Is that what you're talking about? And that's been my experience when I've worked with manufacturers. Well, folks, that is what today's show is all about. Avapco is here to help us with a common language for all these things that we call cooling towers and all the parts that are on cooling towers. And Brett Alexander of Avapco is going to educate us on everything about cooling towers. Well, not everything, but he's going to give us a pretty good lesson on cooling towers. He's going to let us know that just because we call it a cooling tower, its proper name is not necessarily a cooling tower. Folks, I know you are going to learn a lot today, so please welcome Brett Alexander. My lab partner today is Brett Alexander of Avapco. Brett, how are you today?
Hey, Trace. Good to be here.
Absolutely, man. Thanks so much for coming on. I'm really excited about today's show because we have the water treatment world and we have the manufacturer's world, and we don't always communicate in the exact same way. And we're going to fix that today.
Yeah, I'm excited. I kind of started in the water treatment industry a few years ago and then moved over to the manufacturing side. So I kind of have the point of view on both sides, which is nice.
Well, I think that's definitely going to help today's conversation. But before we get started with that, do you mind letting the Scaling Up Nation know a little bit about yourself?
Yeah. So I'm a Midwest kid, born and raised in Wichita, Kansas. Grew up, liking sports, basketball, baseball, while, with school, liking math and science. So I took the talents up to the University of Kansas for school and decided to go engineering route. Originally thought that I wanted to go, petroleum engineering. A lot of my friends' parents growing up were all in the oil and gas industry. And so that was kind of attractive to me. But I kind of was doing some more research and decided to switch over to chemical because it didn't really pigeonhole me so much in just oil and gas. So after graduation, I decided to go into oil and gas. Got a job with Halliburton. I was down in Houston, Texas, and my role with them was actually the drilling fluids engineer, which is a fancy way of calling a mud engineer. So I would go out to the rig when they were drilling the well, and I was in charge of treating the drilling fluid. So when you drill a well, whether it's for natural gas or oil, You drill through, the earth, but you have to bring all those cuttings and the earth back up to the surface while stabilizing the well bore. So, you're doing a lot of the same properties as you would with cooling water, but it's a lot higher pressure and temperatures. And you're throwing in 50-pound, 100-pound bags of stuff instead of measuring to the ppm. So that's kind of how I got my start, treating fluids. Did that for about 3 years. And then 2015 came around, and that's when, the oil prices kind of took a spike down. And so they laid off a bunch of engineers. My rig that I was working on got stacked back. And so they decided to let me go. And I'm telling you that 2 months of being unemployed felt like 2 years. To any of the younger listeners, if you ever go through a time where your company goes down and they have to lay off employees, don't get down. It seems like, a long time when you're looking for a job every day for a couple months, but with our background and our specialties, you'll find something. So I then found a job with, you've probably heard of them before, Nalco Water. They're the big water treatment company, and I really enjoyed my time with them. They got some good training programs, so learned a lot about the cooling water and the health side of it. I was in Austin, Texas at that time. And, being in Texas, there's not too many boilers down there. So I was primarily cooling water application. Started in the heavy industry with them. So power plants, big central plants, and then also transitioned over to their institutional side, which is hospitals, hotels, commercial buildings, data centers. So kind of seeing all the different types of cooling water places that you can go into. And about 2 years ago, Avapco came looking for a kind of chemical engineer. I had been in Texas for about 5 years at the time, and I was kind of ready for, kind of a culture change. And I definitely got that by coming out to the East Coast to Baltimore, Maryland, and joining the Avapco team. So now I'm on the manufacturing side, but we're a little different than a lot of our competition because Avapco actually has a water treatment division inside of the company. So, we sell the cooling tower or evaporative condenser, closed circuit cooler, but we also can then offer water treatment solutions to accompany that. So that's been something different for me, learning from both sides.
Yeah, when I spoke with your boss, Chris Nagel, on episode 37, we spoke a lot about your department. And at the time, that was the only one that was around that I'm aware of. I'm not sure if other manufacturers are doing that, but I can tell the nation firsthand that personally, working with you guys and then you guys working with the Association of Water Technologies, you have just shared some tremendous information that have changed the way of how us water treaters do things, specifically passivation, which I think we're going to touch on just briefly a little bit later in the show. But I want to say hats off to you guys. You guys are producing some amazing stuff, and it's coming from the manufacturer. And for the manufacturer to say, we've done these water treatment tests, we can help provide you with procedures that actually work instead of just seeing in the OEM that, you guys are on your own. Use your water treater and we're out of it. But by the way, if you do something wrong, you're going to violate your warranty. So I just want to commend you guys for doing that.
Yeah, and we're not so much coming in and stepping on the toes of people, with liquid chemical feed systems and stuff. We kind of have a different, more sustainable focused, with a non-chemical type device and then solid chemistry and now like a water efficiency focused pre-treatment system and our passivation research. So it's a kind of a different niche to it, but we like the direction we're going in the industry.
Yeah, I just want to commend you guys for it. And I'm curious, what's the culture shock that you experienced from moving from Texas to Baltimore?
So I traded in my barbecue and Tex-Mex, and now I eat a lot of seafood, is what I tell everybody. But the seafood here is fresh. And when our representatives that sell the equipment come up with their customers, we take them on fishing trips sometimes and going out to the Chesapeake Bay and catching rockfish. And, that's just a fun time.
My favorite crab cake is in Baltimore. It's Fadley's. And every time I go up there, I always make sure I stop there. And once a year, we get a shipment in right around the new year where we get 12 crab cakes shipped to us. And we cook those on special occasions. Have you ever had them?
Yes, I have. And they're the size of softballs.
They're awesome. Yeah. So, Nation, I highly recommend you check those out. Brett, I understand you recently got married.
I did, October 4th. So I was dating Tiffany for about 2.5, 3 years. And when I moved up here from Texas, that's where we met, down in Texas. And she moved up with me to this new place neither of us had lived. And, we lived together for about a year and, it just was right. And so we said I do. October 4th, went on a nice honeymoon in Thailand and Cambodia. And so that was sweet to see that side of the world. I had never been over there before. Not many cooling towers over there.
Well, hey, let's get into the meat of this conversation because I know for a fact, and working with you guys, I tend to call everything a cooling tower. And I know that isn't the correct way. And you say, no, there are specific terminologies for what the cooling tower is actually doing. And that gives us a separate definition. So, Brett, if you don't mind, how do you, as the manufacturer, define a cooling tower?
So we give it a simple definition. A simple open cooling tower is just a big metal box, like the factory assembled one, a big metal box used to reject heat from a building or a process through evaporation. When I'm going to talk about a lot of the stuff today, it's going to be what you'll typically see in the field because there's so many different types of equipment and setups. But I'm going to talk more of the general, what I think the listeners will most often run into and kind of focus on that. So that is an open cooling tower, just the general one where you have the water flowing in to the top of it, and then it cascades down over a PVC fill media. And then you're also having a fan push air or pull air through the cooling tower so that air and water then interacts. Some of the heat evaporates out of the unit. And then that cooler water falls into the basin of the unit that then can be pumped back to the chiller or the heat exchanger or whatever the load is.
But that's not it, because that's what a cooling tower does. But depending on what it actually is being used for and how it's designed, we go a step further and we give them another name. And I believe those names are either a cooling tower, a closed circuit cooler, or an evaporative condenser. So help the Scaling Up Nation understand what the differences of those are.
So what I just explained was a cooling tower, but I like to call it an open cooling tower because that condenser water is open to the atmosphere, right? So when that air comes in, it's directly seeing that water flowing through it. Those are going to be the most common, what you'll see. The other one for HVAC applications that you can see is a closed circuit cooler, or it can also be called a fluid cooler. These look very similar to an open cooling tower, but the difference is there's a coil inside of this. So the recirculating water now falls over the coil as air is moving up through that cooler. So you can think of it, we pretty much moved a heat exchanger inside of the tower, right? So this cooler now has a coil inside of it and you're flowing water and spraying it over the coil. And inside that coil is a fluid, a process fluid. It could be glycol, it could be water, it could be oil for an industrial process, something that needs to be cooled. And some applications you'll see a fluid cooler in is water source heat pump applications. And then also maybe like data centers, hospitals, anything that kind of has a critical process where you really want to keep that fluid clean because the fluid inside of that coil is not seeing the air, the atmosphere. So it's not picking up all the dirt and debris that's getting scrubbed into the tower. So that fluid inside the coil stays a lot cleaner. So I'll tell you the story. The first time I saw a closed circuit cooler in Austin, Texas, traditionally an open cooling tower market. And I go out to this commercial building And they called me out. They're like, hey, we think we got scale on our unit. So I've been about a year and a half in, go out there, open the louver and look inside. And I see this coil inside. And I'm like, had no idea what it was, had never seen one before. And it had white spots all over it. So it was a first of a couple of things, seeing a closed circuit cooler for the first time, and then also seeing a white rusted coil inside, which we'll hit on later, I'm sure.
Yeah, I can't bring you guys on without talking about white rust.
Right, definitely. But yeah, so that was my kind of first time seeing a closed circuit cooler. But the big key to that is if you look inside and you see a coil inside of there, that coil can be galvanized steel or it can be stainless steel, or primarily the two metallurgies you'll see.
And thinking back, I don't think I've seen that many stainless steel coils. I've seen a few, but by far, most of the ones I see are galvanized.
Right. It's definitely the best first cost advantage going galvanized. Yeah, it's hot dip galvanized. The coils are primarily G235 hot dip galvanized. And so the G235 means you're getting 2.35 ounces per square foot of zinc on that carbon steel coil. And so that zinc then acts as the sacrificial anode for the coil, right? The zinc will give itself up before you get to the bare carbon steel of the coil. But of course, those coils then require passivation to extend the service life and make sure you don't have premature corrosion and end up with leaks in that coil.
Well, I tell you what, Brett, how about when we get finished talking about the cooling tower designs, we go into the metallurgies and you can tell us everything that we as water treaters need to know from the manufacturer about that.
Yeah, that sounds good. I'm getting ahead of myself.
No, you're fine. So we talked about a closed circuit cooler, and then we have an evaporative condenser. Now, both of those have coils. What's the difference?
So pretty much the same. An evaporative condenser is pretty much the same as a closed circuit cooler. The difference is what's inside of that coil, the fluid inside of it. For an evaporative condenser, you're going to have a refrigerant flowing through the coil. So ammonia, R22, any of those refrigerant grades. And so where you'll run into evaporative condensers are in like food processing plants, cold storage facilities. So, that's like our refrigeration reps sell the evaporative condensers with like an evaporator system and compressor. So those are kind of the differences in there. And then let's make sure we hit on later some of the differences to what to keep in mind when you treat an evaporative condenser, because they're not the same as a closed circuit cooler.
And we're going to talk about what the differences in our water treatment program needs to be in a bit. But you recently did a webinar for AWT's young professionals that dealt with this. You want to talk a little bit about that?
Yeah, I think that was about almost 2 years ago. Me and a couple colleagues, we did an AWT Young Professionals webinar, and the title was Understanding Different Heat Rejection Equipment and How to Treat Them, from a water treatment standpoint. Just kind of what we're talking about. There's different types of equipment. They require different water treatment, different things to keep in mind. We get into materials of construction. And it's nice because that presentation has, pictures and cutouts of the tower. So when I'm explaining water flowing down the tower fill and the air going up, there's actually pictures that you can go and look at to kind of visualize, because it might be kind of hard to follow me, explaining it over the podcast. But go to the AWT's website and to their library, you can see that. One of our water treatment partners down in Houston, Texas, actually texted me the other day. He goes, "Hey, nice webinar you did for AWT." And I didn't really know what he was talking about at first, but he had to go get some credits for it. And that was one he listened to.
Oh, credits for his certified water technologist designation?
Yep, that was it.
Very cool. I'll try to put a link to that, but it's in the members only section. So unless you're able to log in, it's not going to work. But we'll definitely put a link up to that on our show notes page. The other item I want to talk about is water treaters will call everything a cooling tower. Now you're educating us. No, there are different terms for that. But they're also, we describe them with how the water and the air interfaces. So do you mind talking a little bit about that?
So there's two types of cooling towers with regards to airflow. The first one being counterflow. With a counterflow tower, the water flows down the tower fill media as the air moves up through it. And so they're moving in opposite directions. So that's how we get the term, from counterflow. Most counterflow towers, you'll see you're pulling air into the unit from all four sides. These are primarily what we do from a VAPCO standpoint. We do a lot of counterflow design, so pulling air from four sides. And I'll get into more of that when we talk about treating. So the other one is crossflow. Crossflow towers, you'll have air being drawn in from two sides. So the two ends have that fill media on them. And so now you're pulling in the air from left to right or right to left. And then you have the water flowing down the fill again. And so now the water and air are moving across each other. So terms get the name crossflow tower.
All right. So what about the air?
So what happens with the air, how it's introduced, you either have a forced draft tower, which has a centrifugal fan at the bottom of the unit, which pushes the air through the tower. These typically use more energy, the centrifugal fans, forced draft. Where you'll typically see forced draft units are if they need to be ducted, or it's a low profile type installation where they can't have a tall tower. These forced draft units can be shorter in size. So, for example, in Washington, D.C., they have a law where no buildings can be over a certain height. It's over one of the monument building. So they do pretty much all forced draft cooling towers. And then the other one, which is most common, which you'll see, is an induced draft cooling tower, which has the fan at the top of the unit. It's an axial fan, which is pulling the air up through the tower or inducing it through the fill. So you have a forced draft counterflow tower, you have a forced draft crossflow tower, induced draft counterflow tower, induced draft crossflow. So there's different mixtures of those you can have. So let me get into how the water and the air interact in that fill media. That fill media is typically PVC inside of an open cooling tower. And so the reason you have that in there is the water goes across that fill. It increases the surface area of the water. So then you have more surface area. So then more of the air can contact that and absorb the heat from the water. And then it goes up and you can evaporate that heat out of the unit. And so, you might have 95-degree water coming into the top of the fill. And as it goes down through the fill, by the time it exits, after it's been touching all the air and in contact with it, and now it's about, 85, say, just a 10-degree difference.
Brett, there's no doubt you have educated a lot of people in the Scaling Up Nation about the different types of equipment that we are treating. It's not all just a cooling tower, and there's different ways that they function. Now, you started talking about this earlier. Let's talk about it now. Different materials of construction. And typically what we see out there are galvanized and stainless steel. And there's different types of stainless steel. So, Brett, can you define the different materials of construction and what the different options are?
Yeah. The most common one you will see in the industry is galvanized steel, which is now G235 galvanized steel. So that then has that layer of zinc on that carbon steel, whether it's the panel or the coil, if it's a cooler or a condenser. And Chris Nagel, he is who hired me out of APCO. He has a great podcast with you. I think it's episode 37.
You are right. It is 37.
Yeah. And he gets into like white rust and, gets into the weeds on passivation. We've done, 6-7 years of really passivation research here at APCO on our units, varying different temperatures, different water qualities, different corrosion inhibitors, pH ranges, you name it, we've tested it. And we've actually have a white rust bulletin that kind of, explains that and explains, the parameters of the water chemistry you should keep it in during the passivation procedure, because it varies dramatically from your ongoing parameters. So that's something to keep in mind. We found that the passivation period is not just a couple days. It's not like a pre-clean and flush of new condenser piping. It is, you're actually changing the metallurgy of that new galvanized, whether it's a coil or panel. You're changing it from that zinc to a zinc carbonate, zinc hydroxide layer. So people are like, well, how do I know when that surface is passivated? Really, it's the eye test. You go out there and you look at it, and the new galvanized surfaces will be a nice shiny gray. And I mean, they're shiny. So you'll be able to tell. And then once it's passivated, it'll look like that battleship, that dull gray color. And that means you've changed that zinc layer to a passive film, a protective layer. So that's when you can kind of change over to your normal water treatment ongoing system.
Brett, are you okay if you share that document with us for the White Rust Bulletin, and we can put that on our show notes page?
Yeah, the more people, it only helps us from the manufacturer standpoint. If, the water treaters out there are properly passivating units, then everybody gets less phone calls, right? The startup and commissioning of a new unit is the most critical time. And when we get the most phone calls and, it's, oh, your unit has, bad galvanizing or something on it, so it just saves everybody a lot of headaches down the road if we just have this information out for the industry. And so everybody knows, kind of the research we've done and then what works in your area, what doesn't, because we kind of did research for all over the US and Canada because we sell all over. Our listeners, have a specific region where they do the passivation at. So we like to hear feedback on what you're doing in your area as well.
We definitely appreciate that. And in episode 37, I went on about this, but I'm going to do it a little bit here. Your team and my team has been working very well together for years. And you all have invited me up to see your facility, which is just incredible. And just how you manufacture everything is really impressive. But what I was most impressed about is your department. And you actually have small cooling towers that you will test different formulations, whether you're looking at passivation or some other item, and you actually see how it deals with the different metallurgies that you have and the different cooling towers. I just think that's cool.
Yeah, it's great. We spend a lot of money here on R&D, whether it's, trying to gain capacity of our towers, coolers, or condensers, or it's finding, passivation stuff that works in the field, or a pre-treatment system. So yeah, we spend a lot of time on R&D.
Yeah, and I want to say one of the conversations that I had with Chris, and this might have been 10 years ago, where he was saying one of the biggest factors in passivation was heat load. And before that, I never considered that, but it makes so much sense that if we've got a hot piece of metal and we're trying to passivate it, it's not going to be as successful as if we didn't have a heat load on it. And that has been a game changer in the water treatment community.
Yeah, that's a great point, because I'm going to go back to the University of Kansas days, I feel like. I think it's when you took kinetics, right? I think temperature drives the reaction forward. And the same goes with the corrosion, right? So the hotter the temperature is, the more likely you're going to see that zinc start to prematurely corrode off the coil, which then you'll see as white rust on it. So being able to plan ahead with the end user and get that unit installed and start it up without heat load and run water over it, I mean, that's a huge advantage to having a successful passivation. What we see is we run into a lot of last minute fire drills where it's like, hey, this unit's going online, load's going on it this weekend.
Immediately, yeah.
Yeah, and then it's on the water treatment professional to drop everything and go out there and try to save the day. And that's just, I understand like the frustration that people get sometimes, because it's not fair. So we're trying to educate our reps and the end users that, you've got to have a passivation plan months in advance. Everybody's got to be on the same page. Last minute fire drills do not work. It's too late at that point. So we're trying to temper expectations when that happens and also educating everyone on the importance of planning ahead.
All right, we can spend the entire episode talking about passivation, and I know it would be a phenomenal episode, but we've kind of already done that in episode 37. So let's get on to stainless steel. And we have a lot of different flavors when it comes to stainless steel. So do you mind telling us a little bit about those?
Yeah. When we're talking stainless steel from the evaporative cooling units side, we're talking Series 300. So the main elements in Series 300 are chromium and nickel from the corrosion perspective. So chromium and nickel. And so it's a certain percentage of the chromium and nickel that makes up how much corrosion resistance that stainless steel is. So up until about 2008, all the main players in the evaporative cooling market from the cooling tower side used 304 and 316 stainless steel. And 2008 was when the recession hit. And at that time, what happened is nickel prices skyrocketed. And so when that happened, one of our competitors decided to try to find ways to, kind of cut costs or find different areas where they could, still keep their profits. And they started supplying 301 stainless steel. So now when you talk stainless steel cooling towers in the market, you can have anywhere from 301 stainless steel, 304, or 316. So I'll get into a little bit what the differences are. Comparing 301 to 304, the main difference is 304 has more chromium and nickel concentration. So what does the chromium and nickel do? The difference is with stainless steel, it does not require a passivation plan. When the stainless steel contacts air or water, it naturally forms a chromium oxide passive layer on it. So that's why it's important to keep those surfaces clean so the air or the water can contact them and you get that chromium oxide layer. The nickel comes into play that it helps strengthen that chromium oxide layer. So what it means is generally is more chromium, more nickel, more corrosion protection. So then you can also beef up even more the corrosion protection by going to 316 stainless steel. So now what you've done with 316 is you've added molybdenum. So that tongue twister of a word, which is always fun when I explain this to customer visits, is having people say molybdenum, but us chemists can kind of roll it off the tongue. What that 2 to 3% of molybdenum and the 316 does, it provides chloride pitting protection. So typical areas that you'd see a 316 cooling tower or evaporative unit are coastal environments, right? Because you're by the salt water. So you got high chlorides, or areas where you have high chloride concentration in the makeup water. So when you start cycling up that water, you're going to have high chlorides. And so your risk of chloride pitting or any deposition that follows is higher. So there's different areas where, beefing up to 316 is the right move.
And I'm assuming there's a big cost difference from going to 301 to 304 and 304 to 316.
Yeah, there definitely is. Nickel really drives the cost of the stainless steel when comparing 301 to 304. So you're going to be, a little bit more expensive. I'd say about 10% more, 301 to 304. And then a little bit more from 304, 301 to 316 is the molybdenum. And it was before my days, but we all know that I never used it down in Austin because it was outlawed, but molybdate, as the corrosion inhibitor, but I never got to use it, but it's in 316 stainless steel. So, that really drives up the price.
Now, occasionally there'll be an L behind one of those numbers. What does that mean?
L means it's a low carbon stainless steel. So a lot of our units that we ship out have at least stainless steel basins because that's where the water's sitting. So having more corrosion protection where the water is constantly contacting it is to the end user's benefit. So then you might see a galvanized casing section or the where the fill is up above and the fan section that could be galvanized, but usually the basins are going to be stainless steel. And what manufacturers are doing now, is they are welding the basins. So they weld the stainless steel panels together. And so the benefit of using 304L stainless steel is the low carbon does not promote chromium carbide precipitation. So it's a metallurgy term where when you heat that stainless steel, you can precipitate some of that chromium and that carbon in the steel out. And so then that leaves the weld area a little bit weaker than the other sheet metal.
So as far as the water treater is concerned, when we know that there are welds in stainless steel, we need to be sure that that customer is maintaining that tower properly and cleaning out the basin on a regular basis.
Yeah. So the thing with stainless steel, you think, oh, stainless steel, I beefed it up, the materials of construction, I'm good from a corrosion standpoint. As I mentioned, right, when stainless steel sees water, it forms that chromium oxide layer, right? But when you start, running the tower and sucking in the dirt, the debris, the leaves, you're going to start getting that sludge buildup on the bottom of that basin. And when you look inside and you can't see the basin floor and it's got a layer of 1-inch mud sludge in there, how are you getting that water, that fresh water, or even your water treatment chemicals in that water to that basin, that stainless steel floor? And so that's what a big thing with stainless steel is you can start seeing pitting corrosion because you're not keeping the stainless steel surfaces clean. And then it even goes into the weld areas, like the corners of the basin. When you start getting that buildup too, those welds have areas, called crevices. So you can then start seeing crevice corrosion, which will then look like little pits in the corners and the sides of the basin area. So the big thing I've seen since my time here with Evapco is how critical it is to keep stainless steel basin floors clean.
I keep saying that if you want to know about passivation, go to episode 37, but I'm going to bring us back to passivation again because now we've got customers that are buying stainless steel basins with galvanized bodies. Does that type of system need to be passivated?
That's funny you asked that. I just had a phone call yesterday with a end user and our representative talking this exact same thing. What we did our passivation research, it was primarily for closed circuit coolers and evaporative condensers with a galvanized coil, because that's that heat transfer surface, right? Where the money is, and you want to protect that coil inside the unit. That does not mean you do not need to passivate a unit if it has a galvanized basin or a galvanized upper section. It's just different because the temperatures on a coil will be hotter than the temperatures, say, on the casing section, the upper section of a cooling tower, or on the basin section. So it just depends. It's kind of talking generally. You got to test the makeup water, understanding where you are with the makeup water to start to really understand if you can just run water through that and kind of naturally passivate it. But what we found is natural passivation is not possible if you're putting heat load on that unit, starting it up. You're just not going to be able to just run water over it. But, some people don't want to pay for a passivation plan. And so you kind of make do. You run lower cycles at the start to try to keep the chloride concentration down, keep the pH between a 7 and an 8 during that time, which is very difficult in certain areas, if not impossible. So the passivation is different. We saw a metallurgical analysis come back from a tower, an open cooling tower, no coil in it, and it had a galvanized basin and a galvanized casing section. And it had a significant amount of white rust on it. And the white rust was a concern, right, to the end user, this high school. They were concerned. They're like, well, how much is that going to diminish the service life? So what this metallurgical company went out and did was do kind of a coating analysis. So they, saw what kind of the metal loss was. And what they found was they didn't see too much of a diminish in the zinc coating, even though there was, a good amount of white rust on that basin and on those side panels. So I guess my point here is it is critical to passivate any surface that is galvanized, but when I'm talking more passivation, I'm talking more on the sense of the coil inside a cooler or a condenser. That's where the heat transfer is taking place on. That's when I'm concerned. I'm like, you've got to have a full blown passivation plan for that, and I'm more concerned about that.
Well, let's unpack that a little bit because you're talking about a passivation plan. And I know customers out there, when in doubt, blame the water treater. So I'm talking to all the water treaters now. When you know that there's a new cooling tower or evaporative condenser or fluid cooler, because we just learned all those new terms coming in, we need to talk to that customer and say, hey, do you know we need to do these things to properly pacify that metal so it does not corrode prematurely? Customers aren't going to know that, and then they're going to assume 12 months down the road when they're having issues that your program is not working properly. So again, Brett was very nice to share his bulletin with us. So go to the show notes page. It will have some information on that. And folks, you can charge for this. I mean, this is up and above what your regular water treatment program is. So by all means, you should charge for going out there and doing all the extra stuff that you are doing. Now, the issue we have a lot is we're not notified that a new cooling tower is going in. We show up for our service and we just see a new cooling tower is on the roof. And I don't know what to do about that. We just need to make sure that we're talking to our customers more. Brett, do you have any advice on that?
Yeah, I was going to jump in. That is difficult, right? Because I always preach you got to know the materials of construction and the equipment that you're dealing with. But you can learn those when you first go in and you do like a plant survey at a new account. But you do that if you need to do passivation, then like what we said, it's already too late. So I think at that point, it's just, I guess I don't know job to job how you're figuring out when you're getting these new towers. It's just staying in contact with the facility manager if it's a big central plant or it's a hospital hotel. If they're doing a change out, replacement job, just staying on top with them, be like, hey, I need to know the timeline. We need to talk passivation a couple months beforehand. Because if it's a new account, there's sometimes, a new commercial building across the street and they're like, hey, we know your company. We're going to give you the job. They might not know if it's a closed circuit cooler with a galvanized coil or just a all stainless steel cooling tower, which won't need passivation. So it's just really trying to get the right person that knows what that unit is going to be made out of, what the materials of construction are going to be, finding that right person.
Yeah, definitely communicating with your customer. And I would guess more often than not, most water treaters, I won't say most water treaters, some water treaters do not communicate with their customers as well as they should. Engineers are very overworked these days, so they're always off doing something because they don't have the staff that they used to have, and it's hard to find them. And a lot of times, if we're trying to get so many things done in a day, it takes a lot of time out of the water treater's day to go and find those, but it is so worth taking the time to do that because you might just find a new cooling tower on the roof if you don't.
Yep, looking for that plume. Getting out early in the morning.
Exactly. That's how you prospect. Exactly. When cooler weather and you can see the plume, hey, that's a new potential account. All right, so we've got one more piece of material that we haven't talked about, and that's fiberglass. Can you shed a little light on why they're using fiberglass in cooling towers?
Yeah, so I've got enough information on this, I guess, to be dangerous. Fiberglass is it's made headway in coastal regions more, right? Because it's more corrosion resistant, to the elements in like a coastal region, I guess just the tower components itself. And so what we've seen is that these fiberglass manufacturers will market the tower as, you can run at higher cycles because of what the tower's made up of. But they're just thinking of their tower, right? And we know as water treaters, that tower water, the condenser water is going to a heat exchanger, it's going in piping, and then it's going to a chiller, the condenser tubes, which are not fiberglass or not PVC. So, that's going to limit the cycles. So that kind of, when you start hearing those arguments, it doesn't really, have any impact on how we're going to treat it. Yeah, you just got to think of the entire system, not just what the tower is made up of. And then one other thing we've seen with respect to fiberglass is the UV. The sun will break it down over time. And so those towers will start to look warped and, start deteriorating just being out in the sun, which if they're in a coastal environment, you're probably seeing some sunlight pretty often.
Well, Brett, I have so many more questions for you, but we're just about out of time. So how about we get you to come back next week and you can talk about some of the different designs we have in cooling towers, and then we can get into the meat of proper water treatment from your perspective.
Yeah, that'd be great. I think that's important. So we kind of set the page with, the different types of evaporative units, and then I'll give you some tips and some tricks that I've learned from the manufacturer's side that I think can help you in your day-to-day treatment.
Well, that sounds great. Well, we'll get you back next week. And Nation, you definitely do not want to miss that one. Scaling Up Nation, how much did you learn about cooling towers today? And when was the last time you actually thought about a cooling tower? Cooling towers are something that we do in our day-to-day, but do we really think about all of the internals that make them do what it is that they do? So I think it was just so awesome for Brett to stop by and tell us something new, maybe not new to everybody, but I'm sure everybody learned something about the device that we call cooling towers. I think that is the biggest gift that our industry continues to give back to us, is that we are continuously learning in water treatment. There's always something new to learn. There's always something next to learn. I've said this before on the show. When I first started water treatment, my father told me that the day I thought I knew everything about water treatment was the day that I needed to quit water treatment. Now, he said that because that was his way of saying you simply have lost your respect for this industry. And there's just so much to learn within this industry. If we ever did think we knew everything, I think we all have lost our respect. So tune in for Brett next week, and until then, have a great week, folks. Nation, I think the secret to being successful is aligning yourself with other successful individuals. And that is exactly what the Rising Tide Mastermind is. If you are looking for a group to get you further faster, then please look at the Rising Tide Mastermind. The whole group is designed with that purpose in mind. And if you want to find out more, go to scalinguph2o.com/mastermind.